Here we have a SAT math question. Okay, let's go with the information. The expression 6 times 5th root of 3 to the 5th power times x to the power of 45 times 8th root of 2 to the power of 8 times x is equivalent to a times x to the power of b, where a and b are positive constants and x is greater than 1. What is the value of a positive b? Okay, now let me take the given information. That is, this expression is equivalent to this one. Okay, now let me write the expression, first expression, that is 6 times 5th root of 3 to the power of 5 times x to the power of 45 times 8th root of 2 to the power of 8 times x. So that is equal to a times x to the power of b according to the question. Okay, now let's simplify this expression and write in this form so that we can compare the expression on the left side and right side, and we'll be able to get the values of a and b. So once we get the values of a and b, we can get the value of a plus b. Okay, so here 6 times, since it is a fifth root, it can be written as exponent 1 over 5. That is 3 to the power of 5 times x to the power of 45 whole to the power of 1 over 5. I just wrote this radical with index 5 as exponent 1 over 5. And here we have a radical with index 8. So it can be written as an exponent, that is 1 over 8. So then I'm getting 2 to the power of 8 times x whole to the power of 1 over 8 equals to a times x to the power of b. Okay, here inside the parenthesis, two quantities are multiplied and we have the common exponent. So whenever two quantities are multiplied and we have the common exponent, the exponent can be distributed to each quantity and multiply the results. Then I'm getting 6 times 3 to the 5th power whole to the power of 1 over 5 times x to the power of 45 whole to the power of 1 over 5. So I distributed this exponent to each term over here and I multiplied the results. So the same thing here, two terms are multiplied and we have the common exponent 1 over 8. So what we can do is we can distribute this exponent to this and we can multiply the results. Then I'm getting 2 to the 8th power whole to the power of 1 over 8 times x to the power of 1 over 8 equals to a times x to the power of b. Okay, here let's consider this stuff. The base is 3 and we have exponent 5, and for the complete stuff again we have exponent 1 over 5. So whenever we have two exponents like this, what we can do is we can multiply the two exponents. Okay, let me continue the stuff over here. That is 6 times 3 to the power of 5 times 1 over 5. I just multiply the two exponents over here. The same thing we have to do for this and this. Okay, let me continue. So that is times x to the power of 45 times 1 over 5 times 2 to the power of 8 times 1 over 8 times x to the power of 1 over 8 equals to a times x to the power of b. Okay, here this 5 will cancel out and 5 goes into 5 one times, 5 goes into 5 one times, 5 goes into 45 9 times. So here this 8 and 8 will cancel out. So I'm getting 6 times 3 times x to the power of, so here 9 times 1 is just 9 times 2 to the first power we have here. It can be written as just 2 times x to the power of 1 over 8 equals to a times x to the power of b. Okay, now we can multiply the number 6, 3 and 2. 6 times 3 is 18. 18 times 2 is 36 times x to the power of 9 times x to the power of 1 over 8 equals to a times x to the power of b. Okay, 36 times, here we multiply two terms with the same base x. So whenever we multiply two terms with the same base, what we can do is we can take the base ones and we have to add the exponents. According to the product rule of exponents, that equals to a times x to the power of b. Okay, here 36 times x to the power of, now we have to add this fraction 1 over 8 and integer 9. So whenever I want to add an integer and a fraction, so I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take this 8 as a common denominator. Okay, now when I multiply this integer 9 by this denominator 8, 9 times 8 is 72, positive 1. So now I multiply this 9 by 8. Now I can take this 8 as a common denominator equals to a times x to the power of b. Okay, now 36 times x to the power of 73 over 8 equals to a times x to the power of b. Okay, now the expression we have on the left side is exactly in this form, a times x to the power of b. So the place of a, here we have 36. So the value of a is 36. Let me write over here. The value of a is 36. And at the place of b, we have 73 over 8. So the value of b is 73 over 8. Okay, now I got the values of a and b. Now what I need to do is I have to find the value of a positive b. That is, I have to add a and b. So a positive b equals to 36 positive 73 over 8. Okay, now to add the integer 36 and fraction 73 over 8, I have to multiply the integer by this denominator 8. So when I multiply 36 by 8, I am getting 288 positive 73 over 8. Okay, now I have to add 288 and 73. So when I add them, I am getting 361. So 361 over 8. So the value of A positive B is 361 over 8.